press the bell icon on the YouTube app and never miss another update.
Hello students, today we continue remaining problems in the limit topic. One more type of problem today we discuss. In the last class we discussed two formulas. First one is limit x tends to a, x to the power n minus a to the power n divided by x minus a is equal to n into a power n minus 1. One more we discuss limit theta tends to 0 sin theta by theta is equal to 1. Similarly, limit theta tends to 0 tan theta by theta is equal to 1. And with respect to their problems also we completed. Today we solve some more different types of problems in the limits topic. Okay, we will see one by one. The first problem. So the first problem against the same exercise. I think 17 exercise that I don't know, same exercise problem. So find limit x tends to 0 f of x. Find, observe the concept, find the limit x tends to 0 f of x and limit x tends to 1 f of x. We are finding two values. One is limit x tends to 0 f of x and limit x tends to 1 f of x. So we want the function he has given where f of x. See, observe here, this is very important. F of x 2x plus 3, x is less than or equal to 0, 3 into x plus 1, x is greater than 0, x is greater than 0, 2x plus 3, x greater than or equal to 0, 3 into x plus 1, x is greater than 0. Such a type of function concept you already know in the chapter relation and functions, correct now? So better I explain once again about the function, then we find these two values. See, this function means what? So for that better I draw a number line from minus infinity to plus infinity. The domain is here, the domain is there 0. So the reality of the function is use the function 2x plus 3. Use the function 2x plus 3 when the domain is less than or equal to 0. Up to this. See, observe here. This is very important. Like this. Including what? 0. So in this, if you take the domain less than 0, less than or equal to 0, in that time use the function 2x plus 3. Understand? F of x is equal to 2x plus 3. If we use the domain less than or equal to 0, understand, less than or equal to 0, on that time we use the function f of x is equal to 2x plus 3. Next, one more. So use the function 3 into x plus 1 when x is greater than 0. X is greater than 0. X is greater than 0. So use the function f of x is equal to 3 into x plus 1 when x is what? Greater than 0. Greater than 0, if you take the domain for x greater than 0, then use the function 3 into x plus 1. This is what the concept of the given function. the concept of the given function. The first question. So we are finding at x is equal to 0. X tends to 0. See, observe here, x tends to 0 from left side is 2x plus 3, from right side is 3 into x plus 1. Different functions are given. Beginning problems, what we discuss all the problems in the previous problems. If you take for any domain, the function is same, correct na? That's why, so we use only one function. Observe here, at x is equal to 0, if you approach from the left side, the function is 2x plus 3. Tends to 0, I explained the first class. Tends to 0 means we go near to the 0, not equal to 0. If we approach from the left side, the function is 2x plus 3. If we approach from the right side, it is not 2x plus 3. All the previous problems are from left side and right side, the function is same. That's why we are finding only one value. What we discussed all previous problems, if you approach from the left side or if you approach from the right side, the function must be the same. Means the given function is defined for all real numbers, means from infinity to minus infinity. So that's why we are finding only one value. But here, so if we approach at x is equal to 0 from left side, the function is 2x plus 3. If we approach from the right side, the function is 3 into x plus 1. Different functions are given. In this case, very important concept, we are finding separate limit. For left side approaching, we call it as left hand limit. If we approach from left side, here say I am seeing the left side, I approach us to 0 from the left side, I use the function 2x plus 3, so then that value, that limit value, we call it as left hand limit value. Similarly, observe here, I approach from the right side, so by using the function, I am finding the limit value 3 into x plus 1, then that limit value we call it as right hand limit. When we use left hand limit and right hand limit, so if you approach from the left side and if you approach from the right side, if the functions are different, that is very important. Okay, so when we find left hand limit and right hand limit, if you approach from the left side and if you approach from the right side, for left side is one function, for right side is one function. At that domain, it may be 0, 1, 2, 3, minus 1, whatever it may be. For left side one value, one function, right side one function. In this case, we are finding left hand limit, right hand limit. So left side approaching we call it as left hand limit, right side approaching we call it as right hand limit. Okay, understand? Then when the limit value exists, only when left hand limit is equal to right hand limit. If the left hand limit and right hand limit are same, then only limit x tends to 0 exists. If they are not equal, limit value does not exist. Understand my concept? Limit value does not exist. Once again I say that when we find left hand limit and right hand limit, for the given domain, for left approaching and right approaching, the functions are different. What my point? For the given domain, it may be 0, 1, 2, 3, whatever it may be, left side and right side approaching, if the functions are different, on that case, we are finding left hand limit as well as right hand limit. When only the limit value exists, the limit of the given function exists at particular domain only when left hand limit is equal to what? Right hand limit. This is what the concept of, so what I say in the beginning, so we discuss, in the beginning I say we discuss today different types of problems, means different concept. This is the concept, left hand limit as well as what? Right hand limit. Okay, so here we solve this problem. At x is equal to 0, left side approaching is 2x plus 3, right side approaching is 3 into x plus 1. So the functions are different. The functions are different. So we have to find out individually left hand limit and right hand limit. First one is left hand limit. Limit x tends to 0 in that upper place. If I write minus, this is the notation. See, 0 minus. Okay, prefix if I write minus, this indicates we are not substituting minus 0. Minus 0 is 0. Suppose if it is 1, we are not substituting minus 1. We are substituting 1 only. But this is the symbol. This is the symbol. If I write A minus, this is the symbol. We are going to find what? Left hand limit. Understand? We are going to find left hand limit. Okay, 0 minus, the function is 2x plus 3, 2 into, same concept, 0 plus 3. Left hand limit value is what? 3. Then right hand limit, limit x tends to 0. For left hand I write minus, for right hand I write plus. The function is 3 into x plus 1, 3 into, answer is 3. Observe those two values. That implies left hand limit is equal to right hand limit. Limit x tends to 0, f of x exist. If it is not equal, does not exist, and it is equal to what? 3. This is the concept. Understand? This is the concept. Once again, I explain. When we are finding left hand limit and right hand limit, for the particular domain, if you approach from the left side or if you approach from the right side, if the functions are different, on that case, what we do? We are finding individually left hand limit, right hand limit. When only the limit exists, left hand limit is equal to right hand limit. In that case only limit value exists. If left hand limit is not equal to right hand limit, limit value does not exist. The first problem is over. Then second one. First one, understand? Second one. Second one, limit x tends to 1 f of x. See as that, observe the domain is here. 1, the domain is here. See, for left side approaching, not so far away, we are approaching negligibly small value. That means I start from 0.9, not from minus 1, not from minus 2. So approaching value start is very, very important. It should be very near to that domain. That means I approach from left side, that is for 0.9. Here to approach, negligibly small value. So for right side approach, for left side approach, for right side approach, so we left out this one. Observe here, we left out this one. For left side approaching to 1, right side approaching to 1, the function is same. Understand? We are not approaching from minus 1. Okay, if you are approaching means that value is very near to that domain, not so far away. So I start from 0.9. to approaching to 1. I start from 1.1 to approaching to 1. For those values from left side or from right side, the function is same. Left hand limit is also 3 into x plus 1. Right hand limit is also 3 into x plus 1. No need to find left hand limit, right hand limit. Just simply we find limit x tends to 1 f of x. F of x is what? What we discussed in the previous problems. So answer is 6. So suppose the domain from left side and right side, if the functions are different, understand? So from 0 point minus 0.9 2x plus 3, 0.1 3 into x plus 1, not so far away. So what we start very near to that domain. Approaching value is very near to that domain, understand? So from left side or from right side, the function is same. In this case, what we solved in the previous problem, same method, substitute the value. So answer is 6. Answer is what? 6. Got my point? This is the value we are finding. Limit x tends to 0 f of x as well as limit x tends to 1 f of x. See this problem? Next problem. Next one, second problem in that given exercise, find limit x tends to 1 f of x, where f of x is equal to x square minus 1 equal to 1. Greater than 1. X is greater than 1. So firstly I discuss the function, okay, because if you understand the function properly, then only it is very easy. These two all excluded or not included. The domain is 1. The domain is 1. Okay. Okay. So observe the function. For x is less than or equal to 1, the function is x square minus 1. Including 1. Including 1, the function f of x x square minus 1. If we use the domain less than or equal to 1, on that time we use the function x square minus 1. For x is greater than 1, we use the function minus x square minus 1. This is what? If you use the domain greater than 1, on that time we use the function minus x square minus 1. If we use the domain x is less than or equal to 1, on that time we use the function x square minus 1. So what we are finding here, limit x tends to 1 f of x. For left side approaching, the function is x square minus 1. For right side approaching, the function is minus x square minus 1. So then what we observe here, so for left side function and right side functions are different. Understand? Left side function and right side functions are different. So in this case, what we find? We find individually left hand limit and right hand limit. Left hand limit. Limit x tends to 1 minus. 1 minus indicates what? We are finding. Understand? We are finding left hand limit. 1 minus function is x square minus 1. 1 square minus 1. Answer is 0. Got my point? Left hand limit is 0. So the right hand limit. Right hand limit. Limit x tends to 1 plus. X tends to 1 plus. That indicates what? We are finding what? Right hand limit. In that time we use the function minus x square minus 1. Minus 1 square minus 1. Answer is minus 2. Observe the values. Observe the values. That implies left hand limit, right hand limit. Left hand limit is not equal to what? Right hand limit. That implies limit x tends to 1 f of x does not exist. Limit x tends to 1 f of x what? Does not exist. Observe the problem very carefully. If both the values are same, then only limit x tends to 1 f of x exists. Observe the problem. Next problem. Third problem, find limit f of x where f of x is equal to mod x divided by x. X is not equal to 0. 0 x is equal to 0. Mod x divided by x. If x is not equal to 0, 0 x is equal to 0. So this function we are finding what? Limit x tends to 0 f of x. Firstly, you know in the relation and function, modulus function, modulus, sinum function, that is integer functions, as reciprocal functions, polynomial functions, all these functions you already know. Once again I explain regarding mod x first, then we solve the problem. Mod x, the function, if it is minus x, for what? Less than 0. Correct? If x is less than 0, we use minus x function. If it is plus x, for x is greater than or equal to 0. The speciality of mod is, if you substitute the negative value, the range is always positive. Range means what? Output. Range is positive real number. Correct? So if you want, I draw the graph also. If you take any negative domains or positive domains, this is what the mod function. This is what the modulus function means. the range is always what? Positive. For negative we use minus x, negative domains we use minus x. For positive domains we use plus x. This is what the speciality of the what? Modulus function. Modulus function, the range is always set of all what? Positive real numbers. This is regarding about modulus function. Okay, modulus function. Okay, this after knowing this one, we go for the functions, because here we are finding limit x tends to 0, limit x tends to 0, what? F of x. Okay, x is not equal to 0. Sir, that means what, sir? This is one more very important. If in the given in the function x is not equal to 0, that means use this function for less than 0 and greater than 0. Understand? Use this function. Use this function. Not equal to 0 means the domain is nothing but less than 0, greater than 0. Okay? Less than 0, greater than 0. Okay. Then one by one we split the function first. F of x. If I take what? Less than 0. Firstly, domain what I take? Less than 0. In that, mod x is what? Minus x. Just now I told minus x divided by x. That is equal to minus 1. Got my point? Because x get cancelled. So I write once again here. So minus x divided by x minus 1. This is for x is what? Less than 0. X is less than 0. Then, okay, fine. For x greater than 0, modulus is what? Plus x. Plus 1. Sorry. Plus 1. By x get cancelled, it becomes what? Plus 1. Then x is equal to 0. Here he has given 0. X is equal to 0, the function is 0. This is what all these are all functions. These are all constant function. You know, in the relation function, constant function means range is fixed. Range is fixed. Okay, then that function we call it as constant function. Here the range is minus 1. Giving any domain value, range is plus 1 and range is 0. We write this function in the graph, in the number line also. These are all from minus infinity to plus infinity. Then the domain 0. The domain 0. For less than 0, f of x is minus 1. Minus x by plus x, f of x function is minus 1. Got my point? F of x is minus 1. For greater than 0, for greater than 0, f of x is plus 1. Observe here, there is a gap. Understand? Less than 0, minus 1, greater than 0, plus 1. So at particular domain, x is equal to 0. At particular domain, x is equal to 0. F of x is 0. See, observe here. We are approaching from left side. From left side, the function is minus 1. From right side, the function is plus 1. That means for left side and right side, those functions are different. Correct? Got my point? Those functions for left side approaching, it is minus 1. For right side approaching, for left side approaching, it is minus 1. For right side approaching, it is plus 1. That means what we do, we find left hand limit as well as right hand limit. So we finding what? Left hand limit, right hand limit. Left hand limit, limit x tends to 0 minus, 0 minus, it means what? 0 minus means we are finding what? Left hand limit. Okay, then the function is minus 1. F of x is minus 1. Since I explained in the algebra of limit x tends to a, if suppose the constant itself, limit x tends to a constant, then constant itself, minus 1 is a constant value, so answer is minus 1. Left hand limit value is minus 1. Okay, right hand limit, limit x tends to 0 plus function, it is 1. Function, it is 1. Since by using this result, it is 1. Right hand limit is 1. Observe the values. Left hand limit and right hand limit. Observe carefully. What is the conclusion? That implies left hand limit is not equal to what? Right hand limit. Left hand limit is not equal to what? Right hand limit. Limit. Conclusion. X tends to 0. F of x. Is it exist? Is it exist? No, does not exist. Does not exist. Limit x tends to 0. Limit x tends to 0. F of x does not exist. I think you are understanding. Observe the problem. Carefully you have to observe. Observe each and every steps. You also practice it. Limit LHL. If LHL is equal to RHL, that means left hand limit is equal to right hand limit. In that case, limit value exists, because here left hand limit is minus 1, right hand limit is plus 1. Left hand limit is not equal to what? Right hand limit. Limit x tends to 0. F of x does not exist. Observe this problem. Next problem. Next problem. Find limit x tends to 0 f of x, where f of x divided by mod x is not equal to 0. Equal to 0. Same problems what we discussed in the last problem. Same type of problem. F of x is equal to what is given, x divided by mod x. If x is not equal to 0, 0. If x is equal to 0. We write the function once again. Just now I explained modulus function. For x less than 0 we take minus x. For x greater than 0 we take plus x. So x divided by minus x, so answer is minus 1. for x is less than 0. Correct? For x is less than 0, modulus function is minus x. Understand? Modulus function is minus x. Similarly, x divided by plus x for x is greater than 0. X divided by plus x, that is equal to 1 for x is greater than 0. 0, x is equal to 0. Correct? 0, x is equal to 0. If you want, so no need, if you want I draw the number line also. No need to draw. But if you are understanding very properly, when you draw the number line, you are understanding the properly. It is from minus infinity to plus infinity. The domain is 0. The domain is 0. Then so here for less than 0, f of x is what? Minus 1. Correct? F of x is what? Minus 1. For greater than 0, for greater than 0, plus 1. Then particular domain at x is equal to 0 is 0. F of x is 0. This is what? Overall the function from minus infinity to what? Plus infinity. Got my point? Observe this problem. If we are finding what? Left limit x tends to 0, f of x. We are finding what? Limit x tends to 0, f of x. Okay. If you approach from left side of the limit, the function is minus 1. If you approach from right side of the limit, the function is plus 1. Then what is the conclusion? Left hand limit and right hand limit functions are different, not same. In this case, we are finding individually left hand limit as well as right hand limit. We are finding individually what? Left hand limit, right hand limit. First one, left hand limit tends to 0 minus limit x tends to 0 minus f of x. F of x function is, so answer is minus 1 since constant. It is constant itself. So left hand limit value is what? Left hand limit value is minus 1. Right hand limit, limit x tends to 0 plus. Right hand limit function, it is plus 1. Answer is plus 1. So again by raising. Observe these two values. Observe these two values. What is the conclusion? Left hand limit is not equal to right hand limit. Left hand limit is not equal to what? Right hand limit. Left hand limit is not equal to right hand limit. That implies limit x tends to 0, f of x. Is it exist? No. Does not exist. Limit x tends to 0, f of x what? Does not exist. Observe this problem. Next problem. Next problem. Find limit x tends to 5 f of x, where f of x is equal to what? Modulus of x minus 5. Very simple problem. So mod x, okay, first we write mod x. X less than 0 minus x greater than 0, greater than or equal to 0 plus x. Correct? X less than 0 minus x greater than or equal to 0 plus x. So we draw the number line. Then only you are understanding properly. Minus infinity to plus infinity. We are finding, so this is what the domain. 0 first we write. At x is equal to 0. F of x. So f of x minus x minus 5. Correct? And x greater than or equal to 0, including this one. X greater than or equal to 0. And exclude minus infinity. Yeah? So f of x. What? X minus 5. X minus 5. Then this is what the function. Okay. So what we are finding here? We are finding limit x tends to 5 f of x. The domain is here. The domain is here. Observe here. For left side approaching and for right side approaching, not so far away. What do I take? We take negligible value. Just I approach start from 4.9 from 5.1. For left side approaching, the function is x minus 5. Correct? For right side approaching, the function is x minus 5. Left hand limit as well as right hand limit. In this case, for left hand limit as well as right hand limit, the function is same. We are not taking so far from zero left side of the 0, just negligible value. That means I take start from 4.9. Here start from 5.1, 4.9 to 5, 5.1 to 5. In this case, for left side as well as the right side, f of x is x minus 5. For left hand limit, for right hand limit, the function is x minus 5. So then the conclusion, no need to find left hand limit, right hand limit. Because the function is same, simply we find the limit value. So limit x tends to 5 f of x. That is equal to limit x tends to 5 f of x. F of x is what? X minus 5. Correct? F of x is what? X minus 5. So 5 minus 5. So answer is 0. 5 minus 5, answer is 0. Understand the problem? See, observe the problem very carefully. So answer is 0. Next problem. Next one, limit, limit, next problem, let a1, a2, a3, an be fixed real numbers and define a function f of x is equal to x minus a1, x minus a2, x minus a3, x minus a4, x minus an. Okay, so what he asked what is limit x tends to a1 f of x and find limit x tends to a f of x, where a is not equal to a1, a2, a3, so on up to an. A is not equal to a1, a2, a3, so on up to an. So okay, give one very simple problem. F of x is equal to x minus a1, x minus a2, x minus a3, so on up to x minus an. F of x is equal to what? X minus a1, x minus a2, x minus a3, so on up to what? X minus an. First value, number 1. Limit x tends to a1, f of x minus a2, x minus a3, x minus an. In this case, what we do? Wherever x is present, substitute a1, that is equal to a1 minus a1, a1 minus a2, correct? a1 minus a2, a1 minus a3, a1 minus an. a1 minus a1, 0, 0 into a1 minus a2, a1 minus a3, a1 minus an. 0 into anything is 0. So what is the value of limit x tends to a1 f of x? Limit x tends to a1 f of x, answer is what? 0. Answer is 0. Okay, first value is over. Next, second one, limit x tends to a, f of x, second value. Limit x tends to a, f of x, but a is not equal to, he has given, a is not equal to a1, a is not equal to a2, so on up to a is not equal to an, f of x. So that we cannot answer. Limit x tends to a1, x minus a2, x minus a3, x minus a4, an, x minus what? An. So what we do here, wherever x present, Wherever x present in f of x, substitute a minus a1, a minus a2, a minus a3, a minus a4, a minus a. That is the answer. Correct? Since a is not equal to a1, a2, a3 to an. A is not equal to what? a1, a2, a3 so on up to what? an. This is the answer. Observe this problem. Observe this problem very carefully. Next problem, one more problem. Find limit x tends to 1 f of x, where f of x is equal to x square minus 1, x is less than 1. Next, minus x square plus 1, x is greater than or equal to 1. Minus x square plus 1, x is greater than or equal to 1. So, again, if I draw the number line, it is from minus infinity to plus infinity. The domain is 1. The domain is 1. We use the function x square minus 1. Correct? X square minus 1 for x is greater than or equal to 1 means including 1. Including 1, the function minus x square plus 1. In this case, for left approaching, right approaching, left hand limit and right hand limit we are finding why left approaching the function is x square minus 1, right approaching the function is minus x square plus 1. So, both the functions are different. Both the functions are different. So, firstly we find left hand limit. X tends to 1 minus x square minus 1, 1 square minus 1, answer is 0. 1 square minus 1, answer is 0. Right hand limit, limit x tends to 1 plus, function is what? Minus x square plus 1, minus 1 square plus 1. Again the answer is what? Answer is 0. Answer is 0. That implies left hand limit is equal to right hand limit. Left hand limit is equal to what? Right hand limit. Limit x tends to what? 1 f of x. Exist. Limit x tends to 1 f of x exist and it is equal to 0 and it is equal to 0. I think you are understanding this concept, very important concept. Observe this problem very carefully. Observe this problem very carefully. So, if you know this concept, you can solve any type of problems. If the left hand limit and the right hand limit, both the functions are different, in this case only we are finding left hand limit and right hand limit. Minus 1 plus 1, minus 1, a minus indicates we are finding left hand limit. A plus indicates we are finding right hand limit. Okay, up to this we stop. We continue the remaining problems in the next class. Thank you.